Good morning, everyone. Thought I'd review 11 and 12, even though we're not going to do multiple materials on the exam. I don't want confusion going into it, and I think there's a little. And part of it's probably due to me. So let's go over 11, and I can explain a couple things to you. This typically is the lower stress, right? We know material B is going to be the material with a smaller elasticity. Material A is the larger elasticity. So on this problem, we have wood, right? And then we have steel plates all the way around it of different sizes. So what we have to do is we have to figure out like which one is the control. And I don't think I explained that maybe quite clear enough. So if I say that material B is the control, that would be the pine, and I put the 1250 in here. So this is a relationship that the book gives, stress in A equals N stress in B, right? Now, if I put in N, the modular ratio is huge here, the difference between steel and wood, right? So if I say, okay, then stress A is going to be 17.647 times stress B. And I think maybe I elaborated that we always do that, right? We always put this in as the control. Well, if I do that, then stress in A becomes a pretty large number. Let's look at it. Uh, 9,000, right? So that's still, oh, sorry. I think I messed that up. Let's do that again, because that doesn't compute. All right, that is 22,000. And normally that would be fine, except they gave us this limit of 20,000. So just running this, I figure out that, oh my gosh, that puts, if I make this the control, that puts this over their limit that some expert has created. So that's not the case. And in this case, the 20,000 is the limit. So if I put, here, I'll write that down, 22,058 PSI, and that's not good. That is over the limit. So the control is the other way around, with the steel being at 20,000. So if I put the 20,000 in here, I'll do that off to the side this way. I'm going to run this again, but now I'm going to say, okay, the 20,000 is material A, because it is material A. And then I have 17.647 as my modular ratio. And then I have stress in B. The stress in B becomes 20,000. $1,133, which is under the 1250. So that means that in this case, the steel is the control. So that's super important to know, because now I have 1,133.337, 1,133.337 PSI, and that is okay. And the 20,000 is okay. So this is the scenario for the multiple materials. Okay. And I'm pretty sure I didn't explain that very well in class. So I'm glad you asked for some clarity. Now I can do this. I can run this equation, but this is what I put in for the stress of B, right? So this little equation didn't emphasize that enough. That is how we determine which material is the control. It's not always the weaker material, just like this problem. So Then I can say, okay, the critical load is going to be 133.337 PSI, and then modular ratio of 17.647 times area of A, that's this area. And they did say use nominal dimensions. So nominal means just use the dimensions that are given. And I think it was a 4x8 wood for material A. For material B. Material A is these steel plates. So I'm gonna actually just calculate it real quick. It's 8 times 0.125, and so that's 1, and that's times 2 of them, right? And then it's 8 and 0.25, and 2 of those. Add them together, so that's 6 for material A. And I'm just going to verify that. 8 times an eighth is 1 times 2. Yeah, that's right. All right. And then I have to add to it plus 4 times 8, 32. So the load on this creature is going to be 156.27 kips. 156.27 kips. And I don't know what they have as a solution in the back, but I'm sure hoping it's that. 11. Whoops. They have 136.3. It's not wonderful. Let me calculate it again, because I am pretty happy with what I got going here. Maybe that's the number I put in. 1133.337. Now I get the same number again. Let me just check my area of my steel. That's good. All right, let's check it. Let's check the book's answer, because it's not wonderful that I don't get their answer. 11. So what do they put in? Oh, they have the area steel of 5. How am I mucking that up? They have the area of steel as 5. Interesting. So we assume the steel at allowable. That's good. We did that. And then they run this equation. Oh, they run the equal stress equation. Interesting. To get 136. But what? 2 times 8 times a quarter. I think they have a problem. That first number is 4. Oh, yeah. Sorry, dang. I copied the problem down incorrectly. This 8 is a 4. Oh boy, sorry about that. So yeah, that does change everything because now the area of the steel is not a 6, it's 5. Sorry. Try not to make mistakes because that is confusing, but happens. I'm just running it again to make sure I get their number. Yep. 136.27 kips, same as book. All right. It would help if I would copy down the problem correctly. That is a 4, not an 8. All right, that's good. At least we cleared that up. And I think this is something that absolutely needed to be cleared up. All right, let's do the second one. Same kind of thing. They want to know critical load. And we've got the wood grain here. We're loading this cross section this way. So we are definitely parallel to the grain. So Doug fir parallel to the grain, 7.24 megapascals. Steel, 147. Same kind of thing where they're giving us this control here. I looked this up, but this is given. So I'm suspect again that maybe the steel is the control. So how you check that one more time is this stress in A equals N stress in B. So we know the A material is going to be the steel. We need the modular ratio. So that is, I think, 207 for steel. Let's make sure. E is 207, 10 to the third megapascals. So I'm just going to write 207 E to the 3 megapascals. And then Doug fir. There is a table for SI Doug fir. It's down here at the bottom. And Doug fir is 12, 10 to the third megapascals. So the units are the same there. So 12 E to the 3 megapascals. So for this calculation, it's just the 207 divided by the 12. Because this is all the same. 17.25, a big one again. So let's check it, right? Let's put in the control thinking, oh, Doug fir is weaker. This is going to be the control. And I'll calculate what that would drive the steel up to. So 17.25, stress in B is 7.24 megapascals. So that puts the stress of A at 124.89 megapascals. So 17.25 times stress in B, 7.24 is 124.89. And that is under the steel limit. So that tells me that this is the control, that we do want to drive the Doug fir up to its limit. Okay. So that means we can use our straight up equation, just like we've been doing, to calculate it. P is going to equal the stress in B, modular ratio, area of A plus area of B. And this is the control, so I don't need to calculate a new stress from this relationship. I can just use straight away the Doug fir stress. Okay, so let's see what we get. P equals 7.24 megapascals. Modular ratio 7.25 And that gets multiplied by the area of A, that's the steel. And I think this problem said also to use nominal. Is that true? Use the nominal dimensions. Yes, it did. That doesn't really matter on the steel. That is nominal on the steel. So that's 150 times 10. And there's two of them. So 3,000. That's millimeters squared. So I'm going to have to think about units here to make sure I get everything to work out. But then I'm going to add to it area of A. Using nominal, that's 150 by 150. So that is 22. I'm going to just check that again because I went kind of fast. Yep. All right, so we're good. So I'm going to simplify this. P equals 7.24 megapascals. And I'm just going to turn this into a number. All right, so inside of the bracket, we have 74,250 millimeters squared, because this is unitless, the n value. So now, just to make sure things work out well here, I know that a megapascal is mega being 10 to the 6. So I'm just going to write 724. So now I'm going to move it. There's 3 places, 1, 2, 3. There's another 3 places. And a Pascal is a Newton per meter squared. Correct? Or a kilonewton. I think it's kilonewton. We have brain glitch. Yeah, it's not. A Pascal is a Newton meter squared. So I had it right. All right. But now I have a problem with this, and I got to convert, right? So I'm going to put this 74,250 in there and multiply it by 1,000 millimeters squared meter squared, right? And this crosses, this crosses, this crosses, that crosses, and I'm left with newtons. So I probably want kilonewtons, but I'll just calculate this out. I just start over here. Escape, clear. Okay. 7,240, 1, 2, 3, 74. Looks like I get 537.57. 537.57 kilonewtons. That's what I get. So let's look at the book. Back of the book. I think this is 1112. And 1112. Oh, that's not in the back of the book. There's only odd. So let's go to this and say, okay, what do they get for 12? They get 538. We get 537.57. So we are good. All right. So hopefully that helps with multiple materials and understanding which material is the control. So that's the deal that I probably didn't make super clear. Sorry about that. But to do that, you use that stress equation that has a modular ratio. And you can tell right away just by running that equation, which one is the control. That's different than which one is the A material. A material is always that higher elasticity material. So, all right, hope that helps. I'm going to send an email about the exam, considering pushing it to Thursday. Don't know if that works in your schedule. So if you watch this, look for that email and respond, because it's going to be like a little survey. All right. Good deal. Take care.